Welcome back. I'm in the process of building out my own cloud computing platform using bare metal servers. In the last video, I covered the hardware required, but before I start building out the servers, I need to take a slight detour and cover some fundamental security topics. To get started, we'll take a look at hashing. Hashing is a one-way process that converts data into a fixed size string of characters. To get started, let's look at the fixed size part of the definition. If I take a small string and I run it through a hashing function, we'll get a hash that looks something like this, and the result is called a digest. We can also take a larger block of text and produce a digest of the same size. So you might be wondering, how does the hashing function produce a digest of the same size, even though the starting text was so different? Hashing functions typically operate on a fixed block of text. So if you have a small amount of text, padding is added to fill in the remaining area of the block. If you have a lot of text, then multiple blocks would be used, and any gaps that might be remaining would be filled in with padding, just like before. So the way the hashing function works is each block is sent to a function which produces a fixed output. The output is then chained to the next block, and the last block's output is then sent to a finalizer, which produces the final hash digest. Now, it's worth repeating here, the size of the text being fed into the hashing function could be huge, could be many, many gigabytes worth of data, but the digest that's produced would be the same length in terms of bits. Now let's talk about the first part of the hashing definition, a one-way process. And what this means is you can't take a digest produced and reverse it back into the original text. And that makes a lot of sense when you think about it. The digest will often just be 64 characters in length, and you can't reverse that to get thousands of pages of text back. There just isn't enough information. Okay, this is great, but what is hashing actually used for? Let's say you're downloading an operating system like Ubuntu off the internet. How can you be sure that the image hasn't been tampered with and is authentic? This is where a digest comes into play. You can take any file and run it through a hashing function to create a unique identifier. Here's a page where Ubuntu provides digest for their operating system images. Once you download the file, you can run the same hashing algorithm to make sure everything matches up. So you can think of a digest as a fingerprint, a unique identifier to verify the authenticity of your data. If you take that fingerprint and encrypt it, you now have a digital signature. As I'm building out my bare metal cloud, I'll be using digital signatures for all kinds of things, like creating certificates and validating authorization tokens. In the next video, I'll dive into the next security topic, symmetric encryption. Thanks for stopping by, and I'll see you in the next video.